Hello everyone, and welcome to our session on array operations. Today, we'll be exploring the essential operations performed on arrays, specifically how to insert, delete, and update elements. Arrays are a fundamental data structure used in many programming problems, and understanding these operations is key to writing efficient code. As a visual reference, please see the introductory animation on this slide, which shows an array before and after operations. Let's begin with the insertion operation. Insertion means adding a new element into an array at a designated position. The process involves several key steps. Identify the index where the new element should be inserted. Shift all subsequent elements to the right to create space. Place the new element into the newly created slot. Keep in mind that in a worst-case scenario, especially with fixed-size arrays, this operation can take time because many elements might need to be shifted. Dynamic arrays, on the other hand, may handle insertions more gracefully due to their ability to resize. Next, let's discuss deletion. Deletion involves removing an element from the array and then adjusting the remaining elements to fill in the gap. Here's the process. Locate the element to be deleted, or determine its index. Shift all subsequent elements one position to the left to cover the gap. Optionally update the array size or mark the end of data if needed. This operation typically has a worst-case time complexity of (n), especially if you delete from the beginning of the array, which requires shifting many elements. Additionally, in certain languages, you need to be mindful of memory management and how unused slots are handled. The diagram on this slide shows an animation of an element being removed and the remaining elements shifting accordingly. Now, let's focus on updating elements in an array. Updating means changing the value of an element at a specific index. The steps are very straightforward. Identify the index where the update is required. Overwrite the current value with the new one. Since this operation involves direct index access, it has a time complexity of 1. Updating is commonly used in scenarios where you need to refresh data values without altering the overall structure of the array. On this slide, you can see an animation to demonstrate a simple update operation. Now we have done enough of theory, let's jump into the Visual Studio Code to write all these operations. We are into the Visual Studio Code. We are starting our program by creating a function for each array operation. First, we are writing the insert element function. In this function, we are taking the array, its current size, the maximum capacity, the index where we want to insert the element, and the new value to insert. We are checking if there is available space in the array and if the index is within a valid range. Then, we are shifting elements to the right from the insertion point to make room for the new value, inserting the value at the specified index, and finally increasing the size of the array. Next, we are writing the delete element function. Here, we are accepting the array, its current size, and the index of the element that needs to be deleted. We are verifying that the deletion index is valid. Once confirmed, we are shifting all the elements to the left starting from the deletion index, which effectively removes the unwanted element from the array. We then decrease the size to reflect that an element has been removed. After that, we are implementing the update element function. This function is straightforward. We are taking the array, its current size, the index that we want to update, and the new value that should replace the old one. We are checking if the provided index is within bounds, and if it is, we simply update that position with the new value. Finally, we are writing the print array function. In this function, we are iterating over the array from the beginning to the current size, printing each element so that we can see the final state of the array after all the modifications have been performed. Inside the main function, we are initializing our array with a fixed capacity and a given initial size, populating it with some starting values. Then, we are executing our operations in the following order. First, we insert a new element into the array. Next, we delete an element from a specific position. Then, we update an element with a new value. After all these operations, we are calling our print function to display the final state of the array. This structured, function-based approach is not only making our code modular and easy to understand, but is also clearly demonstrating how each individual operation, insert, delete, update, and print, works on an array. Let's execute it, then you will see the output here. A printed initial array, then you will notice that we have inserted 99 at index 2. And then we have delete the element which is at index 3, and at last we have updated the element of index 1 that is value 55. We are done with the demo. Now let's proceed to the presentation and summarize our learning for this session. To summarize our session today: insertion. Inserting an element requires shifting subsequent elements, which has a worst-case time complexity of O(n). Deletion. Deleting an element also typically requires shifting, resulting in a worst-case time of O(n). Update. Updating an element is performed in constant time, O(1), since it involves direct access. Best practices. Choose the appropriate data structure if frequent insertions and deletions are expected. Consider using linked lists or dynamic arrays when needed. Be mindful of edge cases, such as inserting at the beginning or deleting the last element. Optimize operations by minimizing the number of shifts when possible, for example, batching operations together. On this final slide, you'll find a comparative visual animation that shows the memory view of insertion, deletion, and update. I now invite any questions or further discussion on these array operations. You can drop your questions in comment section. On this note, I am stopping over here. See you in the next session.